Welcome to the meeting number 16 in physical chemistry, whatever, 3, 4, 6, no, 3, 6, 4?
Yeah.
Okay, so you have experienced mathematical challenges, and you recognize that addressing some challenges with computers sometimes can be quicker. Today we are going over basic skills of MATLAB computing, which may help us in progressing the course. And today's stuff is organized as students teach students. So there was no time for me to go over these things. So try to deliver practical stories of success and failures, help your peers to follow success and avoid failures. This is goal number 1. Goal number 2 is to try to be in time, which is really challenging to put dozen presentations in 50 minutes, and we're already 5 minutes later. So I will try to cut if someone is speaking too long. If you haven't seen Microsoft Windows and Microsoft PowerPoint before, check it out. Here are the slides numbered by the order and name of the presenter. So just click here and then click on the tab to go on for presentation. This I would like to invite to the stage Joy Dahlgren to give presentation on the basic use of MATLAB. Yes.
So MATLAB is a calculator. It's pretty simple. You can just type in whatever you need to do for, like, if you need to just do like 17 times 459, it'll pick out an answer. Or you can do the square root of a number. It's pretty straightforward. If you end it with a semicolon, MATLAB will do the calculation, but it won't kick out the answer there on that screen.
Are there any benefits to doing it with the semicolon?
I think when you're writing code, if you have like a bunch, so you don't have all that kicked out, so because it takes up a lot more space. So if you're creating a variable, like I just use some simple ones, like 3.14 of it. I'm just using pi, simple, but you can, if you have like a really long constant that you need to do of some sort, you can just type in a equals blah, 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 or b, and then you can use that to do simple calculations with it as well. And then complex numbers, in MATLAB, they're represented with an I or a J. So if you type the square root of -1, it's always obviously just I. So it'll display the real number if there is a part of the real number, and then the complex number after that. Then I just created a matrix here. So it has the 3 plus the 4 so the real number and the complex number. You can use either I or J. And then you can also do functions with this. So here I just typed in a matrix and then took the max of that matrix, and it'll say, if you have multiple arguments, just put a comma between them. So like the max between A and B, we'll kick out that. And then if you type CLC, that'll clear the command window so you don't have all your other stuff in there. And then these are just some constants that you can use. So like pi is obviously pi, I is magic. So there's just more constants, infinity, I and F are infinity. And then when you're typing arguments, like if you want to label your x-axis and y-axis, so if you just type y label, and then if you want to name it like wavelength or whatever, you can do that. So that's pretty much that.
Okay, let's enjoy. Any questions? We already have one, but thank you once again. I learned about location. It is new things. Next is Gage Winger or Winger?
Winger.
Winger.
Yeah.
Okay. So about graphics, derivatives, and integration and finite differences.
Alright, so I took the word basic to heart here. So this is just plotting a sine wave on the interval of x 0 to 10 with the interval of 0.1. I'm not sure how to make it not do the 0 to 100 thing here, so it's just measuring each x value on that. Which did cause some problems eventually. You just hit plot and then type in plot, parentheses sine x, parentheses out.
Let's check it with the class. How to make anyone can help. Typically, speaker answers questions, but now speaker asks a question. How to make the x label to run from 0 to 10 rather from 0 to 120?
Well, you put a comma after the sign x and then put x, correct? Or
Before,
yeah.
right? So plotting of two arguments, x and y. So
Doesn't have that. That might do it.
okay.
So then the differential here, I have again the same sine x graph. I have plotted the differential here with the dashed line, which represents the differential, which is equal to cosine, which is also, yeah. I'm not sure how to say that other than the derivative of sine is cosine. It shows the derivative of sine is cosine. And then for sums, first I just summed up the x that I've been using up to this point, which gave us, as it stood, like 505, but multiplied by dx is 50.5, so it was adding every single, like 1.1, 1.2, 1.3, and so on. And here I have the summation of the sine wave here. And the solid line here, which kind of shows up, represents the part that's just canceled out by the one period. And then the remaining dashed line is just what it's adding, though there's a chunk of this that should be canceled out too because it's negative, but again, MATLAB was uncooperative. Again, both of these are using the dy and dyyy, which are equal to 1 again. And that's really all I have.
Okay, let's engage. Questions? I have one out of topic. What if you do forget how to use a command? Whom to ask? Is there a help opportunity in MATLAB to get a description of each command?
There's a help window, isn't it?
Yes, you just type in the command, or in the command line you just type help space and then name of the command.
Okay.
Okay, good. More questions? If not, thanks. So the next presenter is Isaiah Seefried.
Oh yeah.
Seefried or Seefried?
Seefried.
Seefried. Okay, so vectors, scalar, and diadic products.
So I have the vectors, obviously. So to create a vector, make sure you use square brackets rather than parentheses. I always set it to equal to some variable. I use a and b here. So you can create like row vectors and column vectors, and that'll come into play a little bit later. To do the column vector, just hit enter afterwards, and it won't like enter in your function until you close it with the square bracket. A quicker way to do it, some people prefer this. You can use the colon method. So you can start it out with just like your initial condition and then what it goes up to. The standard unit is one space, so let's go 0, 1, 2, 3, 4, 5. If you want to change the unit space in between, you can use the initial condition here, colon, the increment you want to increase by, and then the ending number. So it just goes up by 0.5. So you can start at any number you want to for the initial condition, ending condition, all that good stuff. So the scalar product and dyadic product, the scalar product is a little bit different. You need to multiply row by column, not column by row. If you do row by column, you'll get a scalar as a result of just a number. If you use the dyadic product, it'll be a matrix. So it's a little touchy. It's very specific on what it wants you to do. Here we have the dyadic product. You can see I did y times x, so that's column by row instead of row by column. And then you do get a matrix out as your result rather than a scalar.
Does MATLAB automatically detect it?
Yeah.
Okay.
Yep, it'll automatically do it. So if you do y times x instead of x times y, it'll do different things for you. So they are different functions, so it is specific to what you want to do. Another useful skill I found, I only found really one. So if you have like a large set of numbers for some reason, you have like 50 of them, and you want to find like the 47th, in this case I found the 83rd number in the vector, all you have to do is, so my vector was equal to x, I did x regular parentheses 83, it comes out with the 83rd number. Or if you want to find a range of numbers, I did x equals the regular parentheses, I wanted the 14th through the 21st, so I did 14 colon 21, it comes out with 14, 15, 16, all the way through 21. So if you ever need to find like a range of numbers or a specific number in a large set, that would be the way to do it. Yeah.
Okay, let's thank Isaiah. Questions to the presentation? What are Dirac notations? Have you ever heard of them?
I saw it on the student Diadic Product.
Yes, perfect. So later on we will see them in a course. Right now, when we are finding expectation values, it is more, or normalization, it is more related to Scalar Product, and later on we will deal with the operators, and they can be also related to Diadic Product. More questions? If not, I thank Isaiah once again. Next presenter is Kailyn Reed, and she will introduce us into the world of operations with matrices. Thank you, Seth, for bringing it for.
Okay, so I had matrices in MATLAB. So he explained what a row vector is. How you type in a row vector is you do, like I just chose A as my variable, you do A equals bracket, and then you can either put commas in between all of the numbers, or you can do spaces, and then it'll come out as your row vector. And how to do a column vector is similar. You just, well, I mean, I did like all zeros for this one. So you can, if you want to do like all zeros or all ones, you can do z equals zeros and then how many you want. So 5 and then 1 column. So that's how you would do that. If you're doing like regular, like more than zeros, then you would just do A equals, and then you would type square bracket, your numbers, hit enter until you have all of your numbers, and then another square bracket, and then it'll give you your column vector. Okay. And then how to type a 3x3 matrix in MATLAB. So that's the first one, so you can ignore that. But then you type the same thing, square bracket, your numbers with comma or spaces in between them, and then when you want to type the next row, you put a semicolon in between your first row and your second row. And then you can also do matrix operations in MATLAB. So if you want to add 10 to all of your numbers, you can just type in your variable for your matrix and then plus 10, and it'll add 10 to each of your numbers. Or you can take the sign of all of your numbers. You can do cosine, tangent, really any single operation you can think of. Okay, and then how to transpose a matrix in MATLAB. You just type A and then a single quotation, and then that'll transpose your matrix. Okay, yeah, and then this is kind of describing what an invertible matrix is. Like, here's the equation. This is the identity matrix. I'm sure you all know what that is by now. That's just the definition. Here's the formula for inverting a 2x2 matrix. So you just, or the determinant, sorry. So you just do 1 over A times B minus B times C times your new matrix. And then this is the matrix solution. So X equals your inverse matrix times B, which would be a different matrix. Okay, and then this shows you how to take the inverse of a matrix. So you just type, so like, if you have your matrix X, which would be this, if you want the inverse, you have to choose a new variable for your new matrix. So I just did Y, and then you do inverse regular parentheses of X, and that'll be your inverse. And then here's the definition of a determinant, which you can see in this equation right here. And then this is how you find the determinant in MATLAB. So you have to type in your matrix first, and then you just do D equals determinant of A, and then your determinant will be -32 in this one.
Okay, but thank Kailyn. And I know you all are super excited about matrix operations and problem operations. I do have one. Can you scroll back to 3 slides? More? Here.
This one?
Forward, yes, here. So you found that Y is inverse of the X matrix. If you are suspicious and you do not believe MATLAB, how to check that Y is really an inverse of X?
You can use the inverse equation.
No, just in MATLAB.
Oh, in
check for
MATLAB?
self-consistency.
I think I wrote that down in my notes, but I don't remember how. I think
Anyone? Yeah.
Wouldn't you just multiply
Yeah.
y times x?
Just the inverse of Y. Or just do what? Oh, yeah.
why
Okay,
does
so
Y times
you've got 2 answers. Both are great. So I almost know your names, but you spotted this easier. Michael
Yeah.
told that make inverse twice. Inverse of inverse should give original matrix.
Yeah.
If it is correct, right?
Yeah.
And Alex told that if you multiply inverse by original matrix, what should you get?
the original?
No. You have presented it. Let's scroll back.
This one?
More. Here.
The
So if-
identity matrix.
Right. More questions about matrices? If no, let's thank Kailyn once again. And right now, Joseph is going to help us to immerse deeper into science of matrices.
You might have to help me too.
Yep. And I promise next time it will be real photo.
Okay, so I was assigned to go over the eigenvalue problems of MATLAB. And, a little hard to explain. And so for doing eigenvalues, having an eigenvalue in a matrix, a simple 2x2 square matrix. And what the program will be doing is a linear transformation in which the determinant of the matrix equals 0. And I have a affinity matrix here, defined by the eigenvalue E, the unknown that we're looking for. And so then what happens is, I get looking for this and this, we subtract this times this, so we get this 2x2 square matrix. So then I have the subtracting the unknown E here and here, and forcing it, the determinant of this to equal 0. In this equation here at the bottom.
What is unknown in this equation at the bottom?
The unknown would be the
Yes.
the E, the eigenvalue E.
Yes.
And this is just the Wikipedia screenshots, a little own study. And this is a screenshot of the example from class. So we have the simple 1, 2, 3, 4 minus the unknown E's, making it equal 0. So then you just do the A times D, so 1 minus E, 4 minus E, subtracted by B, C to find the determinant of the square. And then you just get this polynomial minus 6 equals 0, so you get E squared minus 5E minus 2 equals 0. So at A, B, C, take the quadratic formula to solve for E. That gives you 2 answers, which is a 5.4 and -0.4. Now, the example I did was a 3x3 matrix, which I did do a 2x2 for some reason. I thought to show it does work on a 3x3, but it doesn't show good for confirming that it gets the same values, which it does. But, so first we do this, you guys define your matrix, it would be any matrix. They did it a different way than the previous person did. Also, semicolon, just add a 1, 2, 3, enter, get a new line on the matrix. And then the operation you do in MATLAB is bracket u comma v bracket space equals space I parentheses a, so the matrix that you defined. And I learned that if you don't put these spaces here, it will hate you and not do anything you want it to. And then the V is a diagonalization of the matrix that solves, which if I was to do the, what if I would have done this matrix, the MATLAB would have shown the 5.4 and the -4 would have showed up in the diagonalization. So these are the eigenvalues that would have showed up. And they would have matched if I would have showed them, but I didn't. And these are would be your eigenvectors, show up in the columns here. And so yeah, using MATLAB is a lot quicker and easier than trying to do a pen and paper.
Done?
Yep.
Okay. Any questions you always wanted to ask about eigenvalue problems? I do have. Yeah. So why some people call eigenvalue problem diagonalization of a matrix? It's a confuse. Like some people, is it the same? Is it different? Why it is semantic things?
Oh, when you
Just your idea, either certain knowledge that you know for sure, or just guess.
well, it's found to be the same as when you're diagonalizing a matrix on a linear algebra problem. You end up with the answers on the diagonal of the matrix, and the rest will be zeros.
Yep. Anyone has different opinion, or agree with it? So if we do linear transformation of a basis, then a matrix in a specific basis can become a diagonal. And by the way, the matrix formed of eigenvectors, if you take this u and u minus 1 and multiply them from front and rear to the original matrix, it will form this one. So in the basis transformation arranged by this matrix, the original matrix will come into diagonal form. Why it is needed? Because you will see it later. The Hamiltonians in quantum mechanics are often non-diagonal, and eigenenergies, eigenvalues of energies are results of transformation of Hamiltonian into diagonal basis. Okay? We will come through this verbal formula again and again. More questions to choose. If not, then thank you once again. And Ben is and Ben Geffre is going to finish story about matrices and start story about visualization.
So, yeah, doing two completely different topics, well, kind of completely different topics. Very short. So, visualization of a matrix and difference in MATLAB between exponential of a matrix and matrix exponential of a matrix. So, visualizing a matrix. Well, here I have my sample matrix that I will use for all 4 examples. So 2 that I found that actually give you something meaningful are bar of A, which gives you a nice bar graph showing all your values, and bar 3, which gives you a 3D representation. And here I just have it rotated in 2 different ways, just to show you. So, and the first topic. So second topic, exponential of a matrix and matrix exponential of a matrix. So here is the exponential of the matrix A in the previous problem, and then matrix exponential of matrix A. So exponential of a matrix is simply take each term in the matrix and take the exponential of it. It's pretty simple. Matrix exponential, you could probably do like 2 entire lectures on, but it's like actually taking the exponential of the matrix, and it's defined by that infinite sum. So yeah, that's it. So.
Okay, let's thank Ben. Any questions to the speaker? I think it is clear. Let's thank him once again. And give stage to Dillan, who is giving us more details on how to visualize numbers which are boring, converting them into figures that are pleasant.
Okay, so I did plotting 2D, 3D, and surfaces in MATLAB. So plotting in 2D, so this is just a basic sine function that you got to define your x terms, which I'll kind of go into a little bit more, and then your actual function, and then you just simply, for 2D, just write plot, and then your x, and then your variable. So you're kind of like your x is line space. When you type your line space, you gotta you have to choose your x1 is your starting point, your x2 is your ending point, and the n is like the number of plots that it's gonna show. So if you type in 100, it's gonna be a nice fine line. If you type in like 2, it's gonna be really choppy. So here I did multiple functions. I just did. Well, I defined my, your x's, so I started from -2 pi to 2 pi, and then my 2 variables were sine of x and cosine of x, and then I chose, so you just define each at once. So I did plot your x and then your y1, and then you do the hold on to say that you're going to type some more, and then you got to type your y2, and then plot your x and your y2, and then that'll plot it. Make sure to put your semicolons, because then it just won't let you do it because it's not correct. And some other things that you can do is you can kind of change how your functions look by simply just, I added the O for your plot, my first function, and then I ended up making a circle for my sine function, and then for my second function I ended up doing a star, and then that changed my other function to just being a star throughout the interval. 3D functions, I found it was most useful to just type your percentage 3D plotting, and then again defining your x, and then I just did cosine of x, and then for your z you can pick anything that you want, and then just make sure to write plot 3 and then your x, y, and z terms. So that plot 3 is what makes it into a 3D function. And then this is just kind of something extra. It's the same function, everything, except for instead of plot 3, I went and typed comet 3, and you can't see it in the figure, but once you hit a plot, it just traces what the cosine of x would be. So it's just a little bit something extra. And then for surfaces, It's a little bit more complex, but not too bad. You just keep your percentage 3D plotting, and then I ended up switching to tangent x, and then your z, you kind of have to multiply your x and your y, and you have to then also define a matrix, which I did here. I just did a 1 by 50 and then or a 50 by 1 and a 1 by 50. And then you just type surface and then your x, y, and z. And then I also did a peak. So basically you got your surface and then you say you want to plot that surface, and then you type in your peaks, and you can vary like how many. I picked 100, and it just kind of just pumped all that out. It's just kind of something you have to play with. And then here's just one more example, except for this time I added mesh, so it's just a different kind of form, just gives it a different look.
Okay, let's continue. A lot of information to absorb in a short time. Can you scroll to slide number 5?
Yeah.
So, any questions? While you are developing your questions, I'll ask mine. Who needs stars? Why do or circles?
I don't know. I think you can just kind of. I don't know if you really need it. It's just kind of something to help, visualize. If you have multiple functions, I think, and then you can define your different functions with that, by setting variables or like.
Like a legend.
Yeah, you're on your legend and stuff like that.
So, any practical circumstances when you really need this stars and circles?
Really, you have two kind of like graphs that are sort of similar, but they're like different. So like in my earlier presentation, they had like a dash line, like derivative. Just kind of like these like.
Yes. More. Yes.
Looks like you're doing a ton and you run out of colors to do.
Okay.
If you're playing tic-tac-toe on MATLAB?
Sure. More ideas? And
You have a black and white printer.
yes.
Print it.
Anyone who is involved in actual experimental research in wet or instrumental lab or visits labs.
Showing the relevancy of the compounds. You have like recording wavelengths, or proposing wavelength graphs could use the different figures of the plots that are incredibly close to each other, showing where they cross over and come to reaction.
Yep, this is correct, and this is specific. We can tell more generally. But if you do measurements through experiment, there are always errors, good or bad, due to objective or because of the not sober human error. But the observables are always scattered. And we want to derive natural laws from them. So people make fitting functions coming through experimental data. And in these circumstances, what you presented is especially useful. So you put this shaky data from experiment through symbols, and then you put fitting line or theory line through them as a continuous trend. More questions? If no, let's thank Dillan once again. And Morgen Hagerott, will you tell a story about how to format figures? Or maybe there will be some surprises. Let's check.
Okay, so I had kind of like formatting figures, so things like font, like size of lines, things like that in the graphs. So, or like another thing you can do is you can change the background. So, like if you have a graph and you want to lay like a picture behind it, if you have your graph pulled up and then you
bring like a picture into the window as well, you can use this code right here. And some of these are just kind of like, these are just instructions along the way. But you put this in, and then what these will actually allow you to do is lay the graph on top of the picture without actually covering any of the graph. So it just kind of like adds kind of a different background to the data. And then to change font or font size, you go up to preferences, and then it'll kind of bring down this little menu here, and then go into fonts. And then from there, you can change whatever like type of font you want, and then like plain or bold, and then you can go over farther and make like a larger font or smaller font, depending on what you want to use for your graph or anything like that. And then last is like line thickness and color. So like if once you have like all of your code in that plots out like a graph, if they're like really small and you want them to be larger, what you do is you just copy this in into the code just below, and h is just an arbitrary constant. So depending on how many lines you have, so if you have like 4 lines, you could use A, B, C, and D and use them differently so that you can change each one. And what you'll do actually is you will copy in here, you will copy the plot points that give you that function or line. And then here is kind of like another formatting thing. You can choose what the line will actually look like. And then under here, you want to make sure that this is the same as this, whichever, if you're changing to a different variable. And then line width, you can change it. So if you want to make them bigger, you just make that number bigger. And then if you have like a bunch of lines on your graph, you want it to be more clear, you can make it smaller. And so that's kind of how you do that there. And then when you're plotting, a way to change the color is you just put in like different letters. So like R is red and different things like that. So that allows you to change the color of the lines to make it easier to kind of differentiate between them. And that's it.
Okay. Good. Thanks. Questions? I do have one. So this is a really advanced way to modify figures that deals with more like programming, if you write a code. But if you do something really quick in that command line, is there a way to do the same change of line thickness without typing much? Or would you anticipate such an opportunity?
I didn't see any of that, but
any in the audience want you help? No? You did it. So in the when you open MATLAB, there is a screen and there is a little arrow to modify in the upper bar, and then you just double click on a line, and there pop up menu with like color, thickness, so you can do it in mouse operated regime really quick. Okay, so when you play with it next time, try to do it, because your way is more correct. Yeah. But this one is practical shortcut. More questions? Morgen? If not, let's thank him once again. So you present a very important skill. So it is a skill superior to visualization. What is superior to visualization is animation, because some of us think that the goal of the course is to predict future. Future is always dynamic, so you need always.
Awesome. All right. So we're going to do animations in movies. Like Professor Kailyn said, this is very important when it comes to visualizing what your graph is doing and maybe what you're trying to see what the electron may be doing. All right. So there's really 4 techniques, but 3 basic techniques that we can do are update the properties of your graphics. So you can open up your graph, look at the properties, change them, and see different animations and how that can work. You can also apply transforms to objects, so you can orient your object in a certain plane or in 3 dimensions. You can also create a movie, which is kind of one of the more important ones you need to know. That's where you really get your graph to move and change and actually see what's going on in motion. And the last one is writing a video that you can save for later and use in like a research project or something else. So the first one where we're changing the properties, so simply you have your graph open, you simply just go click on edit, edit your graph properties, and simply just on the side here you can change your x data, y data to change how your graph looks. Second technique where we're changing the orientation of our graph. This is a little more complicated where you have to do something called a transform. Essentially if you have all your data all together, you can use the command HG transform, and then you can use the command matrix. This will allow you to transform and adjust the position of all the properties of your shape so you can actually look at what's going on. And then the other one, more important one, creating a movie. For this one, you want to use the get frame and movie function, mostly get frame. So here in my command, you really want to use get frame command. That'll get you the movie. And this was also kind of depicted in Dillan's presentation earlier. But if I have my set of data here, I can actually have it move up and down. So I don't have a video of it because it was very brief, but essentially these two peaks flipped when I played the video. It would show the two peaks going up and down based off using the command get frame and move. Optimization, so this is really, really brief. You can optimize all these settings to how you want them to play out. You can update the properties consistently. You can basically avoid legends when doing animations. Legends will kind of complicate things. But you can always optimize the properties to make it how you want. Yes? No? Please? There we go. Okay. How to write your videos. This is probably the one thing you will need to know the most. For writing a video, your most important commands are frame, get frame, and write video lead frame. Essentially what this does, it allows you to visualize what you're doing in your graph. So here from yesterday, we had our graph. And so this is what the animation will allow you to do by using get frame and write video. I'll play it one more time. But it allows us to actually play out the graph of what's going on. There we go. Okay, so kind of still going back to the full kind of command list. You have set of commands. So creating the video writer specifically is video writer and open. But again, the more important one when you have your data, so like in this case, when we had our graph yesterday for k equals 1 to 20 and for our sine function, you want to do frame, get frame, and write video command. That'll actually get the video to actually play out like we saw earlier with the graph actually moving. Other than that, once you have your data, it's very simple to go through the command steps. And so this is just from yesterday. Oh, it is video, okay. So this is just, again, how that video works with the write video and get frame.
Okay, let's thank Bill. So it is your chance to get skills of making movies.
Just ask Alex.
No, you'll better ask him. How did you upload it to YouTube? Is it standard?
How did I upload it to YouTube?
Yes.
So you can download the movie, you can save it from MATLAB onto the desktop, and then you can upload it through your YouTube channel.
Okay. And which command would be to change the name of the file that you are saving? Can you scroll back to your list of commands? Like, what's the name of the file that you need to upload? Anyone can.
Can you just change that to your comment?
No. When you are running the code, it creates a file. So what will be the name of file here?
Want to be peaks?
Dot what?
Maybe.
Yes. So if you want to do something else, you just change this line. Okay. So
So yeah, so v equals video variable.
Mhm.
Peaks.avi, you can change the name.
Okay. More questions? If no, we'll thank Bill once again. Very important presentation. And we have two presentations more. Alex Hart and Michael Odegaard is in front. So they are bringing us from the basics, matrices, and visualization to the world of programming. So they are giving us first steps towards programming, which is includes in one of the presentations it was like making set of commands in a script that you repeat, and there, in addition to commands, if, then, cycles, you also need to save data, read data, and run the codes. So data will be processed by Alex.
So yeah, variables. So if you want to see like the list of all your variables and matrices that you have, you type who, and then it gives you a list of all of them. So from our code the other night, these are all the variables that he had in that one code. I think it was like homework 5 or something. To see a size of a matrix, you type in the size and then the name of the matrix. So IK in this case would be have one column, no, one row. No, it should have one column and 607 rows, but I think it reads one column, I mean one row, and then 607 columns. So if we this is just some. These are both the same size, so this is just a slide for the precursor. And if we want to create a new matrix off of old matrix, we can type in answer as the name here. And then if we do whatever the matrices were, and then put a prime, it stacks all of their data right up into one row. So this is just 2 columns with 102 rows, I believe. And then what did I actually do? Oh. If you want to plot that data, it looks really nice, I know. You just type in plot, and then the name of whatever the variable was. In this case, it was answer. And if you put the 2 dots, I believe that's a semicolon, and then a comma, and then 1, that'll give you the first column. And if you do that for the second column, it'll give you the same thing, and it'll give you a graph. This isn't a very pretty graph, but it was the data I had. To save it, you just type in save, and then the name of the desired name of the file, and then the name of the matrix you have, and then if you put -ASCII, it will give you a text file. It'll save it as a text file with 2 columns with all the data, and it should, that's just where it is. It's in the folder that you are currently working in, and then this is what it looks like with all your data. If you could compare that, it would be the same. It just has, like 10 to the -1 is what that notation is. So to open it in Excel, you have to go to Excel, and when you hit File, Open, you can go find, you can browse, and you just go to the place where it's at, in this case, Documents, MATLAB, and you have to make sure you switch it to all files, not just Excel. That way you can actually find it, and then when you open it, you hit Yes to trust it, because it doesn't know if it should trust it or not. You do have to change it from what a delimited to fixed width, because if you leave it in delimited, it'll put all your data in one column. But if you put it at fixed width, in a second, you will see that, oh, this got cut weird. All the data goes into 2 different columns. So then once it's in Excel, you can use that data in a nicer and easier way. One more thing before questions, it was, in order to load a variable, you just type, if it's in that same folder that you're working in, you can like type load answer, and it'll load it into your workspace that you're currently working in. I forgot to put that on here.
Okay, excellent. Let's thank Alex. Any questions how to load or save variables? Or it was crystal clear? Let's thank you once again. And last but not least is Michael. So he is the starting program in MATLAB. Maybe first steps, but very important.
Okay. Yes. Okay, so first to load, save, and run, first you got to get the script. So I got the one from the email, and I just downloaded it. And then you click on it, and then it'll come up here. And then to save it, you click on save. And you want to, this is the way I did it. It seemed the easiest. So I did the C drive. And then I did users. And then I did my name. It'll be your name. You're logged into it. And then I click on document. And then MATLAB. And then saved it. Okay. So then like you can save a ton of scripts under your name, user, or if you have a flash drive, whatever. So to bring them up, to run them, you just hit, or you type in ls.
Looks like Matrix movie.
And then you highlight the part, but don't do the .m, because if you highlight the .m, it won't work. And I was really confused one day. But so you just highlight it, and then hit enter, and then it runs. And then that was the movie that came up.
Yeah! More questions? Well, we will go over, it was the first steps. Later on we will do like programming by running cycles and doing things for, but more questions? If not, let's thank Michael once again. So let me bring back your happy faces. So there is a big hope that through your excellent presentations, you got a little bit more familiarity with running MATLAB, and we will be able more and more replace practice in analytical derivation to just little writing scripts and just getting data to percept concepts rather than technical details. Let's thank all speakers of today's session. And Alex wanted to announce...
We're done, guys. Let's go.
It was a adjourn message. Done.
Oh, sorry. Meeting adjourned.
Forgot to say we all got A's.